Do you ever wonder what the future holds for me? All I know is that I am told that you learn from your mistakes. So, I guess that since I make so many mistakes, that must mean I'm going to be a genius. Now, if you ask me that same question, I may not be able to tell you all the details about what I want to be when I grow up, or even what the world of work will be like after we graduate college. But I can tell you one thing is for sure. Here at Wylandville Elementary, we are learning and developing our academic and social skills such as problem solving, creative thinking, perseverance, patience, organization, and collaboration through coding in the classroom. This will set us up for success no matter what career or interest we decided to pursue.
When people hear us, they say that we are learning computer science and coding. They usually ask, what is coding? Our answer is that coding is based on many different languages that computers understand. We get to tell the computer what to say by using block-based or text-based coding languages. Then the computer gives output based on what we just coded.
As fun as it is to impress people by educating them on what coding is, the real reason we're here today is to talk about a problem. Most digital things we do involve code, but only a small percentage of the world actually knows how to code.
For example, how many of you have searched for something on the internet? Probably every single person.
How many of you can read this code? Would you be surprised to know that this code is what is used to display the results from a simple Google search for the word school?
How about this question? How many of you have used an automated system like self-checkout at a grocery store, got money from an ATM, or controlled anything in your home using a remote or smartphone like this temperature, lights, music, movies, locks, or even your car? Believe it or not, all of those systems are similar to the Scratch projects we created during Cycle 1. All of these systems run on code. By coding a machine with input to produce a certain output, to do things for us is just the type of coding we have been practicing.
We are in the middle of a digital revolution, with coding and computer science becoming bigger and bigger parts of industries like agriculture, medicine, fashion, architecture, sports, energy, public safety, art, food service, banking, and entertainment. It is becoming more and more important that we learn about computer science and coding so that we are prepared for the jobs of the future. We aren't all going to grow up to be computer programmers, but we will be able to use this knowledge in any job we choose.
In Cycle 1, we started our computer science journey by learning the fundamentals of computer science through visual block-based programming. Visual block-based programming is useful for people who are new to programming because it is easy to read and use.
In Cycle 2, Making and Robotics, we continue to learn the fundamentals of computer science through visual block-based programming, but we extended our learning to include both hardware and software. This hands-on experience with robotics helped to make programming easier to understand. By having to control a physical robot and seeing what goes wrong, we learned what robots can and can't do. We also learned about the need for precise instructions.
In grade 1, students learned about freshwater habitats. In science, in the classroom, students constructed an aquarium with live guppy fish. Next, they created a Minecraft-themed fish habitat in Scratch. Students then coded their guppy fish to teach facts about freshwater habitats.
In grade 2, the students built Bluetooth Lego robots, which they coded to move about. This process helped students understand the connection between hardware and software. Some good second graders coded their robots to travel around Pennsylvania, sharing facts about our state. Others coded their robots to tell realistic fiction stories involving the technology characters and their superpowers. In grade 3, the students created large continent maps to display physical features while their robots traveled through each continent explaining different iconic landforms.
To start becoming familiar with JavaScript in 4th grade, we used the Make Code app developed by Microsoft. The Make Code app is a very useful, powerful tool that allows you to modify the game Minecraft by writing code. We really did not spend much time playing Minecraft in a traditional sense. We spent our time coding Minecraft. To code Minecraft, we started by using blocks that were very similar to the ones we used in Scratch. As we became familiar with this new platform, we deepened our computer science knowledge by learning about syntax, variables, and nested loops. Then, as we became masters of visual block-based coding, we could instantly convert our code to text and start to become familiar with real-world text-based coding language, JavaScript. Looking at JavaScript can seem very, very overwhelming at first, but it became more manageable as we observed the code to look for patterns and similarities between the block code and the text code.
Both Java and JavaScript are very important. Despite having similar names and sharing similar syntax, the two languages are actually very different. JavaScript is generally more front-end and runs directly in a web browser like Chrome. JavaScript helps to make over 90% of the world's websites fun and interactive. Java is generally more back-end and needs special software to work. From laptops to data centers, game consoles to scientific supercomputers, cell phones to the internet, Java seems to be everywhere.
So now you might be thinking, wow, these students are learning some amazing things, but aren't these robots and virtual agents going to take all of your children's jobs? What will they do for work?
Will robots and virtual agents take our jobs? That is a great question. It is predicted that almost 50% of our jobs will fall victim to robots in just a few decades because of advances in things like artificial intelligence. Artificial intelligence is also called AI, makes it possible for machines to learn from experience and to adjust to new inputs and perform human-like tasks.
Logically, your next question is probably, well then, what jobs are safe? We really don't know for sure. Experts tell us that we automate a lot of their repetitive work. We are going to see an increased demand for creative skills. Since robots lack creative skills, humans will be the ones filling in those positions.
In addition to being able to working on and alongside robots and virtual agents, we are going to see an increased demand for people with strong social and interpersonal skills, who are caring, persuasive, having great negotiating skills, and are good at selling. These are exactly the soft skills that we get to practice in our classrooms when we are learning about the coding and computer science.
Through our work with computers, Legos, and lots of different software platforms, we have also been developing our confidence, patience, problem-solving, collaboration, focus, and communication, all of which will be required when we enter the workforce of the future. So, to sum things up, we have been learning lots about the technical parts of coding and computer science, as well as the soft skills that will help us find or create jobs that are robot-proof, and we are really happy about that. Our futures are looking really bright.
Speaking of the future, we hope you enjoy exploring some of the coding projects we have been working on for the past few months. We are glad to have you here to support us as we code our way to the future. After you leave here today, be sure to tell everyone you see not to worry about the future, because here at Wylandville Elementary, we are practicing all of the skills that will help us make the world a place where
Awesome is the new